Good morning, students. Today we are going to learn the nuclear chemistry, the health and its safety aspects. So first we are going to learn the biological effects of radiation. There are two basic effects. The first one is acute or short-term effect, and second is chronic or long-term effect. Acute or short-term effect, it is generally caused by exposure of high-dose radiation over short period of time, and this shows effect very rapidly. This effects generally seen during nuclear weapon explosion or nuclear reactor explosion. There is a history for that. In Hiroshima Nagasaki bomb explosion is one of the examples. Second, Chernobyl accident which was occurred in 1986, and this effect generally causes a death of living beings. Genetic effect, this effect is suffered by offspring of the individual exposed. It involves the mutation of very special cells, that is reproductive cells like sperms or egg cells, and pass to the offspring of individual exposed. Means the radiations are directly affecting to these reproductive cells, and because of these radiation, the cell's mutation will change. Okay, there exists a spontaneous mutation and it will change the behavior of that individual. Second is somatic effect. This primarily suffered by an individually exposed, and it is an occupational risk. Here the workers, those are working in radiation exposures, are generally suffered by these. Generally, uranium miners are suffering by lung cancer. Radium dial painters are generally suffered by bone cancers. Thyroid radiation therapy patients are generally suffered by thyroid cancer. So this is what the somatic effect or carcinogenic effect will be seen in different people. The symptoms of somatic effect is a loss of weight, fever, loss of appetite, rapid heart action, severe diarrhea, and loss of hairs. Chronic radiation exposure even causes skin burns, blister formation on skin, increase in cancers, radiation sickness, and even death. Third one is in utero effect. It is a special case of somatic effect. It involves a production of malformation in development embryo. So the malformation produced is not considered as genetic effect, since embryo is exposed, not reproductive cells of the parents. Here the developed embryo is exposed to the radiation, and because of that the behavior of that particular individual gets affected. In utero effect is observed depending on stages of fetal development. So for 0 to 1 week there is intrauterine death, 0 to 7th week development abnormality, 8 to 40th week there is a functional abnormality. Next, hazards in radiochemical work. So these hazards arises from sealed or unsealed sources are different. Sealed sources generally causes external radiation hazards, and open source causes internal, external and contamination hazards. Radiotoxicity. The ability of radioactive material to produce injury by virtue of its emitted radiation once it reaches a susceptible site of body. Means the injury occurred by radiation over a body, it's called radiotoxicity, and it depends on half-life of radio sample, types of radiation emitted and its energy, and the location of a body where that radiation is applied. There are three categories of radioisotopes depending on radiotoxicity: high toxicity, medium toxicity and low toxicity. So these radiation needs to be protected. So how to protect these? So radiation protection. So the protection of people from harmful effect of exposure to ionizing radiation, and the mean for achieving this is called radiation protection. Means we need to protect the living beings from this radiation. Okay, which are the different methods and how it is to be achieved? Normally we are surrounded with n number of radiations. So radiation is a part of our life, and the radiation that is always in the environment is called background radiation. The majority of background radiation occurs naturally, for example sunlight, and a small fraction comes from man-made elements. Like man-made element radiations are like our mobile towers, radio signals which is sent by different radio stations, also during some nuclear explosion, etc. So these radiation protection principles. The radiation protection principles involve three basic and fundamental principles. The first is the time, distance and shielding. As you can see in this particular slide, keep this away distance means as you increase the distance, the effect of radiation decreases. Shielding, use proper shielding material depending on which radiation is exposed and the extent of radiation. And third one is time. Shortening the time will favor for less effect. Means the individual should expose to that radiation for a minimum time. The time should be maintained minimum, distance should be maintained maximum from the source, and the shielding material should be used to protect an individual from radiation hazards. The shielding material will be chosen depending on type of radiation and its energy. For alpha radiation, a thin piece of paper or air is used. For beta particles, sheets of aluminium, brass or plastics are used. For X-ray and gamma radiation, lead is used. And whenever they are involved more than one kind of radiation, then the radiations which are penetrating first will be shielded first, then the radiation which is having higher shielding capacity.